In this video, we're going to think about using chemical reactions. And so what we want to think about is not just how they can balance and what they mean, but how we might be able to use that in a chemical situation or in a chemistry lab. So what can an equation tell us? We know that an equation tells us the ratios of the different elements, and we can use that to calculate the product. So if we want to make an ice cream sandwich, we have 2 cookies plus 1 scoop, and that's going to give us 1 sandwich. And so in this reaction, we can start to think about the relationship between cookies and ice cream in order to make this ice cream sandwich. So if we start with 20 cookies, how many ice cream sandwiches could you make? Likely, immediately you knew the answer was 10. And so the way we're going to use that same information that you already know is to use the stoichiometric coefficients. So the stoichiometric coefficients are these numbers here. And so we know that the cookies and ice cream are in a 2-to-1 relationship. So we know that for every 2 cookies, you need 1 scoop. So we could write that chemically as a conversion factor where 2 cookies gives you 1 sandwich. And in this case, you get 10 sandwiches. So this allows us to convert from a reactant to a product or reactant to reactant. And we're going to use the stoichiometric coefficients in order to do that. So let's look at a more directly related to a chemical example. So in this case, it says using the balanced combustion reaction below, how many moles of CO2 would be produced from 22 moles of octane? Now, octane is C18H or C8H18. So in this case, I'm going to slide the slide up a little bit. And so in this case, we are going to convert octane to CO2. So we want to go from here to here. So if we start with 22 moles of C8H18, we want to convert that into carbon dioxide. So for every 2 moles of C8H18, we create 16 moles of CO2. So in this case, when we plug this into our calculator, we're going to take our 22 moles, divide by 2, multiply by 16, and that's going to give us 176 moles of CO2. So we can convert any product or reactant to something else using the stoichiometric coefficients. The stoichiometric coefficients are the big numbers that we develop when we balance chemical equations. So moles are helpful, but in previous videos we talked about how moles are not enough. We want the ability to measure things in grams or kilograms or things that we can use on a scale. And moles, there aren't any moles scales. So we can start to use some of the skills that we already know. So we can already, if we have grams of a substance, we can use the molecular weight to determine grams in 1 mole. So this is the molecular weight. And so we can convert using the molecular weight. And now we can use the stoichiometric ratio. Metric. And this is going to allow us to convert from, in this case, I'm going to say red grams and red moles. And we're going to be able to convert into blue. And these would be moles and moles. And then we could again use the molecular weight of 1 mole in grams of both of the blue compounds to where we can now directly convert through a very long process to go from grams of one all the way down to grams of the other. And so we can do this with skills we already know, being able to convert grams to moles, and we're just going to add in the stoichiometric ratio. These are the big numbers in the front of a balanced chemical equation. So let's look at a specific example. I'm going to scroll this up, and I'm going to take the eraser and, erase this, and I will re-add the words molecular weight since they got erased. So in this example, magnesium hydroxide is the active ingredient in milk of magnesia, and it neutralizes hydrochloric acid, the hydrochloric acid in stomach acid. So what mass of HCl would be neutralized by a dose containing 3.26 grams of magnesium hydroxide? So what do we want to do? We want to convert magnesium hydroxide to hydrochloric acid. And we want to do that using the skills seen up at the top. So we want to take our mass of magnesium hydroxide. So we're going to go 3.26 grams of MgOH2. And now we need to convert that using the molar mass. So for magnesium hydroxide and 1 mole of MgOH2, there are 58.33 grams. Now, the stoichiometric ratio in this case is 2. Oops. Slide that over a little bit. 2 to 1. And so in this case, we are going to use that relationship. So for every 1 mole of MgOH2, we need 2 moles of HCl. And then we need to convert back to grams. So for 1 mole of HCl, that weighs 36.46 grams. And so you'll notice that I wrote out all the units. The reason we do that is because we can color code these. We could go from magnesium hydroxide to magnesium hydroxide to moles of magnesium hydroxide. And now we're going to switch to hydrochloric acid. And so we can, using that stoichiometric ratio, transition between the two. And when you plug this in your calculator, you should get 4.075 grams. And this should only have 3 significant figures. And so that would be 4.08 grams of HCl. So using a balanced chemical equation, we can now convert from grams to moles, moles to moles, and moles to grams. So let's look at another example. So a scientist mixes together potassium chloride and lead 2 nitrate. If they start the reaction with 38.21 grams of KCl, how much lead 2 chloride in grams should they collect? So we are asking about this value here. And so this is a balanced chemical equation, so we can use that. So now we're just going to write out the same type of conversion. So we're going to take our 38.21 grams of KCl. We're going to convert that into 1 mole of KCl. And so in this case, it's 74.55 grams. And now we need to convert potassium chloride into lead chloride, lead 2 chloride. So there are 2 moles of KCl for every 1 mole of PbCl2. And in this case, there's 1 mole of PbCl2, and that weighs 278.10 grams. So when we plug this into our calculator, we should get 71.27 grams of PbCl2. So we're able to convert from one to the other. So this asks a slightly different question. How much lead 2 nitrate is consumed in this reaction? So now we want to go from potassium chloride to a different reactant because we know they're consumed at the same rate in order to make products. So we're going to take our same 38.21 grams of KCl, divide by the molar mass of 74.55 grams, and 1 mole of KCl. Oops. And there's 2 moles of KCl for every 1 mole of PbNO3, 2. And the molar mass of lead nitrate is 331.22 grams of lead 2 nitrate in 1 mole. And so the amount consumed is 84.88 grams of PbNO3 2. Now, you may have had a question about the molar mass of potassium chloride. And so I'm going to highlight what we're going to talk about here in red. So you may have thought that because there are 2 moles of potassium chloride, that you should have multiplied this 74.55 times 2. And so you don't need to do that because the stoichiometric ratio, highlighted here in green, takes care of all of that information. And so what we're able to do is to convert grams to moles and use the stoichiometric ratio to convert between the two. So it's just convert to moles and then the mole relationship and then convert back to grams. We don't need to account for the stoichiometric ratio in the molar mass. So let's look at another example. And so in this case, we have solid lithium hydroxide. And it's going to be used to remove carbon dioxide exhaled by astronauts in space. Lithium hydroxide reacts with carbon dioxide to form solid lithium carbonate in liquid water. How many grams of lithium hydroxide are required if 250 grams of carbon dioxide is exhaled by the astronauts? The first thing we need to think about is, what is the balanced chemical equation? Before we can do that, we've got to think about what these compounds are. So lithium hydroxide is LiOH, and lithium has a +1 charge, and hydroxide has a -1 charge, solid, plus CO2, which is a gas because it's being exhaled, and it's going to create lithium carbonate, which is Li2CO3, and this is solid, plus H2O, which is a liquid. So this equation is not balanced, and so we can see that because the number of lithium on the right does not equal the lithium on the left. So we're going to add a 2 here. And so once we do this, there's 2 lithium on both sides. There's 4 oxygens, and so we see those 4 on the other side, 1 carbon and 2 hydrogens. So this is a balanced chemical equation. So now we need to convert carbon dioxide into lithium hydroxide. So this doesn't ask about the products, it just asks what is the relationship between 2 reactants. We could have asked how much lithium carbonate is created or how much liquid water is created, but this is going from CO2 to lithium hydroxide. So we're going to take our 250 grams of CO2, and the molar mass of CO2 is in 1 mole of CO2. We have 44.01 grams of CO2. And the stoichiometric ratio is 1 to 2, so 1 mole of CO2 for 2 moles of lithium hydroxide. And 1 mole of lithium hydroxide weighs 23.95 grams. So now we can convert grams of CO2 to grams of lithium hydroxide. When you plug this in your calculator, you should get 272.1 grams of lithium hydroxide. So this is the amount required based on the amount of CO2 that is being exhaled. So this is how we can use a balanced chemical equation. We need to remember 3 steps. 1, convert to moles. 2, use the stoichiometric ratio to convert from moles of 1 to moles of something else. And then we can use the molar mass to convert back into grams.